Dear students, welcome to the 8th class. This is the continuation of the same class I was doing in the last. I drew this diagram. This is a very important diagram in HVAC system. This is very important diagram in HVAC system. You have to remember this diagram in totality. This is often asked in HVAC system, and when you become an HVAC engineer, this coordinated diagram plays the most major role during the building layout designing of HVAC system. So you should be very particular about knowing this diagram. I think you can understand this, what I am telling. I will explain it again. This is the corridor of a building. You understand building corridor? As you pass out of the room, you go through a common corridor through which all the rooms are on both sides and you pass through. It is there in all the hotel. What is a hotel lobby or corridor? What is a hospital? There is a corridor and cabins are there on both sides. So this corridor is the place through which you move in a building. From one room to another, from one part of the building to another. Corridor is very essential. Whether in a shopping mall, whether in a hospital, whether in any other building. Now, corridor is the place where all the services run above false ceiling. Now, your first question will be, what is false ceiling? False ceiling is to cover the cement concrete on the top. A designed fabricated sheet of false ceiling is generally made at below the top level. A designated false ceiling is made. If I show you like that, this is the roof level. This is the roof level. This is the roof level. This is false ceiling. Here is the ground level, through which floor level, through which you are moving. When you look up, you will see this false ceiling. You won't see all the services between false ceiling and the roof. In houses, we don't generally provide false ceiling. For your information, in houses we do not provide false ceiling. But in case of big buildings, false ceiling is a must. It is there in all the buildings you go. Whether it is the airport, whether it is a hospital, whether it is a shopping mall, when you see at the top, that is not the concrete ceiling, that is the false ceiling, which is designed by the architect. It is given a beautiful design so that a person feels the aura of the building as they enter inside. Now, between this false ceiling and the roof or the ceiling level of the building, there are a number of services running through the corridor. Why it is through the corridor? Because through the corridor you transmit the pipes and ducts from one side of the building to another side. Transferring chilled water pipe to different FCUs, AQs, etc. Transferring the pipes from one building to another through another corridor. So corridor is the main place through which all the services run. Corridor plays a very important role, and this height of the false ceiling from here to here plays more important role. Inside, there is total chaos regarding so many services coming in above the false ceiling, and there is a tendency of false ceiling lowering down. Lowering down false ceiling gives a very bad view of the building. See, you are entering into a big building, enter into the corridor and see a false ceiling very low. That's it's like falling on your head. You have a very frustrated feeling. So the false ceiling should be located at a location where you have the proper height of the building. Proper height of the false ceiling from the floor level. So that when the person moves in the floor level, he gets a comfortable position that the false ceiling height is high enough. Now, there lies the challenge. These are all the services you have to accommodate within the false ceiling. Now I'll give an idea about these services. You can see I am putting dimensions. I am putting the dimensions, different dimensions. This will be having. All dimensions are in mm. Remember, it is in millimeter only. Now try to understand this dimensioning very well. This dimensioning is very very important. It is minute dimensioning here. You have to have a better view of that. I am telling also to try to follow what I am telling. This dimension from the bottom of the false ceiling to the floor level, we are taking 270 diameter. That is around 8.5 feet. This is just the OK level of false ceiling. A false ceiling should be around 3000 mm. But in corridor, getting a 3000 mm in a place like Nehru Place or congested place like Palika Market is difficult. So there, if you get a 2700 mm, you are lucky. You can understand a 6 feet man walking here get a 8 feet, around 8.5 feet height. So it's just okay. He can just feel comfortable. He won't feel that false ceiling is falling on his head. Above false ceiling, this false ceiling, you can see, this false ceiling has a thickness, false ceiling itself has a thickness of 75 mm. 75 mm, 3 inches. 25.4 mm is 1 inch. So 75 mm is actually approximately 3 inch. Above that, there is chilled water pipe, there is condenser water pipe. Above chilled water pipe and condenser water pipe, there is an insulation layer. Not in condenser water pipe, this is condenser water pipe, this is chilled water pipe. One is supply, one is return, one is supply, one is return. Above chilled water pipe, there is an insulation, but in condenser water pipe, there is no insulation. Because the condenser water pipe moves at atmospheric temperature, it does not require insulation above that. But chilled water pipe requires insulation because this passes chilled water from the chilling machine, which is at very low temperature. This is provided in insulation outside. One reason is that there is no heat loss from the chilled water. Number two reason is that in case of chilled water pipe, number two reason will be that there is no condensate formation at the outside because there is chilled water. There is chance of condensate formation outside, and if condensate forms, it will come to drop through the false ceiling, and through the false ceiling, whole false ceiling will be wet and whole structure will be gone. So, to save that, an insulation is provided on the chilled water. This insulation is generally 50 mm thick. Above that chilled water pipe, we are putting supply air duct and return air duct. Supply air duct is this cross sign is supply air duct. This one line drawn diagonally is return air duct. Both are insulated. Supply air duct is insulated with 50 mm thick insulation. Return air duct is insulated with 25 mm thick insulation. Above that, there is a roof, and in the roof there is beam. You understand beam? If you see roof structure, there is beam in the roof, and beam takes the load of the building. That means in a building, if you make a hole here or puncture here or make a breaking in the roof here, nothing will happen. But if you do something in the beam, if you make a puncture, you make some structural arrangement in the beam, you break the beam, the building will fall. Beams are the load bearing members. They take the loads. So when you are designing the whole system, it should be sufficiently below the beam so that you have enough maintenance space over there. Now how it happens? We have taken 2700 mm as the false ceiling height. Above 2700 mm, there is 75 mm thickness of the false ceiling, as I said. Above thickness of the false ceiling, there is a 150 mm gap between the outside surface of the chilled water pipe. Remember, it is including insulation. The outside surface is including insulation. These dash signs are insulations. So, bottom of the insulation to top of the false ceiling should be having a distance of 150 mm, 150 mm. That is around 6 inches wide. Because there are cable tray, that is electrical cable tray. This is the electrical cable tray through which electrical fittings will be running, and here the bulbs will be put in the false ceiling. Here there will be bulbs. In false ceiling there will be bulbs here. These are the small bulbs in false ceiling. There will be bulbs for lighting in the false ceiling. So keep the false ceiling lighting. You are to put this cable tray above that, and the cable tray requires a clear space of 150 mm. So we keep 150, it is mandatory. 150 mm between the bottommost part of the chilled water pipe to the topmost part of the false ceiling. Above that there is 50 mm thick insulation. This is 50 mm thick insulation. We have taken 50 thick. Along with that, the pipe diameter. I have taken here pipe diameter 300 mm. So 300 mm pipe diameter. Above 300 mm pipe diameter, 50 mm thick insulation is again there. This is the pipe diameter, means the inner wall of the pipe. And outside the pipe dia, there is 50 mm thick insulation again. Between the 50 mm thick insulation, the top cover, and the bottom of the insulation of the supply air duct, there should be a gap of 100 mm. Why 100 mm? So that you can put your hand inside, can do the maintenance work and put these things in place. This is 100 mm. You need a 100 mm gap here to make the proper maintenance work. Remember, this is 100 mm. Just see very, very minutely you see this 100 mm. This is 100 mm. Why? Because there is hanger of the duct. It is hanged by a channel. So you can put your hand inside, can do the maintenance work and all these things. So 100 mm is 10 cm. 10 cm you need at this place to move. That is around 4 inches. So that you can move your hand inside that within 4 inches. Above that, then there is 50 mm thickness of the insulation. This is 50 mm thickness of the insulation, 50. Above that, there is 500 mm. I have taken the height of the duct. 500 mm. Above 500 mm, there is 50 mm insulation again. Above 500 mm, there is 50 mm insulation again. And above 50 mm insulation, there is 150 mm gap between the beam. This is beam and the top of the insulation of the supply duct. That should be 150 mm. Why 150 mm? Again, you have to put your hand and you have to do maintenance work. You have to do some structural work or something. You need 150 mm, around 6 inches above that. So you can see, if you add all these if you add 75 plus 150 plus 50 plus 300 plus 50 plus 100 plus 50 plus 500 plus 50 plus 150, that makes the total clear space you require for the services to run. You can see so many dimensions you have between the false ceiling top and the bottom of the beam. This should be the clear space. Just have a look towards that very nicely. I give you 1 minute to have a look so that you can have a clear idea of this. Now, after putting all the services together, the false ceiling height should be sufficient enough to accommodate person inside. It's not easy. What happens in a site? In a site, the HVAC man makes drawing of these ducts and drawing of these pipes, chilled water pipe and condenser water pipe. The firefighting man does the firefighting pipe. The plumbing man does the plumbing drawing pipe. Cable tray man, the electrical man does the cable tray drawing. All these drawings are put together and coordinated at site. Like every service will give, try to understand, every service will give a separate drawing of them, because you as a HVAC engineer don't know what is plumbing drawing or what is firefighting drawing. So the firefighting man can make a firefighting drawing in the building. In firefighting, you understand, no? If there is a sprinkler on the top of the building, you can always see the sprinklers on the false ceiling of different buildings. The sprinklers, whenever there is fire, the sprinklers have a molten metal which gets melted at high temperature. So whenever there is smoke or fire, it gets the sprinkler metal melted, and as a result of that, it is full of high pressure water. Water will fall totally in the building, and that dousing the fire. So throughout the building, firefighting pipe will also run through the corridor, through all the rooms, everywhere. Plumbing pipe, this includes your water pipe, hot water pipe, cold water pipe. All these water pipes you require for your bathroom, you require for drinking, you require for all these things. These are running through this plumbing pipe. And in hospital buildings, other than this firefighting and plumbing pipe, there is a gas pipe also through which oxygen is running. Say for example, in big hospitals like AIIMS, Gangaram, in such hospitals, you have piped supply of oxygen. You know, in COVID-19 cases, there is a breathlessness of the patients. For the breathlessness of the patients, the oxygen line is there in the room. They put off the plug, they put a connection there and connect to the ventilator. Connect to the ventilator on the nose of the patient, and oxygen gets supplied. It's an old system having separate oxygen cylinders. In big systems and better systems, there is no cylinder mechanism. It is the gas pipes which are running. So you have to accommodate gas pipes also throughout the building in the case of a hospital. So we have other services like firefighting, like plumbing, which are also include drain pipes. Drain pipes are also very important. You are having different bathrooms from where drain pipe is being taken. This drain pipe runs through this firefighting pipe. Sorry, to this plumbing pipe throughout the building. So plumbing pipe are 2-3 pipe plumbing pipes. I have shown one plumbing pipe, 2-3 plumbing pipe. One is cold water, one is hot water, one is drain pipe. These all are running in the same, in between this false ceiling and the roof. You can understand. Then comes the HVAC system. Now you can see from the diagram, firefighting pipe is a small one, plumbing pipe is a small one, other water piping is small one, gas piping is small one, but the maximum space is being taken by the HVAC engineers. Big supply air return duct, big chilled water pipe, condenser water pipe, then all of them are insulated. So the highest space is taken by an HVAC engineer. And I will tell you genuinely, the fact is that the architecture never likes an HVAC engineer during a project. If it is possible, he will throw him out. But he cannot throw out because HVAC is mandatory. You have to make the building air conditioned in present day. In big buildings have to be air conditioned, whether hospital, whether shopping mall, whatever it is there. So HVAC is to be accommodated. And whenever HVAC is to be accommodated, a big space is taken by it. There is no other problem when you accommodate a firefighting pipe. This is a small diameter pipe. Red pipe you will see running through the building, small diameter pipe. Plumbing pipe, there are 3 pipes, plumbing pipe, cold water, hot water and drain pipes, small diameter pipes. See, I have taken a diameter of 300, it may become, at the beginning it may become also 3000 mm here, 3000 mm high, the diameter of the chilled water pipe in case of a big building. 3000 mm, you understand, it is around 10 feet, the diameter of the pipe, 10 feet, diameter of the pipe of HVAC. That means 10 feet plus insulation plus supply air duct, all these things will go. So, architectures, the first job the architecture does in a building coordination, he calls for HVAC drawing. First to fit the HVAC drawing, then he fits the other services. क्योंकि other services के पाइप जो है छोटे छोटे हैं, आप कहीं भी एडजस्ट कर सकते हो उसको. But you cannot adjust the HVAC systems which are having bigger pipes, bigger supply ducts. You know what is this supply duct width can be in case of a big building where it is just coming out of HU. It can be 2000 mm, 2500 mm. 2500 means 2.5 meter. That is around 8 feet. 8 feet is the width of the duct. Height of the duct may be around 600. That is around 2 feet. You are understanding what dimension I am talking about. How is the space will come? The more dimension you take here, the space falls. The false ceiling height falls further. And more the false ceiling height falls, the building becomes tremendously exhausted. It is very chaotic building. Architect never wants to make the false ceiling height less. Because false ceiling is the identity of the architect. ये पहचान है architect का. वो false ceiling design करता है. He designs the false ceiling with utmost care. He makes. You go to big buildings, big shopping malls. You see on the top how beautiful false ceilings you will see with such a good design. He doesn't want to distract that. So he feels HVAC engineer is his enemy. I am telling the facts because of these big dimensions we carry. अगर HVAC का सारा सिस्टम नहीं होता, तामझाम नहीं होता, ये chilled water pipe, condenser water pipe, supply air, false ceiling height would have been much higher. Architect would have been very happy because this is a small firefighting pipe, small drain pipe, small other pipes going, gas pipes are going. So these are small pipes. So he have easily manipulated the higher false ceiling height, but he cannot do it because of HVAC. So HVAC is very critical for buildings for 2 reasons. One is space. It takes maximum space in a HVAC system. And number two, one is space, what is very important constraint for HVAC. And number two, I will discuss later. So this is the way the whole HVAC diagram is to be diagnosed and is to be coordinated. I think clear about the drawing. If you have any question, you ask me over phone. You go through the drawing first, understand the drawing first, and later on ask me question over phone, ask me question over email, ask me question over chat box, whatever means you want. And when this lockdown gets over, I come there. You come with the drawing if you don't understand something. Come with the hard copy of the drawing. And above all, now the best advantage is that all these drawings will be saved in YouTube. You take from there and save in your hard disk. Because I don't know. Tomorrow YouTube may remove them. So it's better to save these drawings, my classes in the hard disk. As you see my classes, you can get all the drawings, records. I think you are clear with the whole concept of this drawing is very, very important in HVAC system. When you become an HVAC engineer at the beginning, you handle this, the maximum. Maximum part you handle is this. You always coordinate with the architect. There are meetings with the architect. They are with the architect. You fight with this, you fight with plumbing, you fight with firefighting, and you make your system work. Remember, this duct can be flattened. I told you aspect ratio. Remember the word aspect ratio I talked about that. Aspect ratio is the width by height. Or I can say height by width. If it is height by width, the maximum is 1:8, you can flatten it. If this is 1, this is 8. If this is 100 mm height, this is 800 mm height. But you cannot flatten further. You cannot make it 100 and 900 mm. Not even 100 and 850 mm. Up to 1:8. Because architect will always tell you to flatten the duct. I told you in aspect ratio, when aspect ratio is 1, it is the best duct. That means aspect ratio 1 means width by height is 1. Or height by width is 1. But that is not possible. So they generally make the height by width to a maximum of 1:8. उससे ज़्यादा अगर इसको expand कर दोगे, the turbulence will be created in the HVAC system, the airflow, and there will be no laminar flow. You won't get a proper cooling within the room. So see, you have restrictions everywhere, but the architect will always tell you to put these diagrams having the maximum duct flattening, and you have to tell the point, sir, this is 1:8 now, and I cannot further flatten the duct. I cannot flatten. That's all. You have to put your foot down at a certain point. I think it is clear. We are coming to the end of the syllabus. We will finish the syllabus very shortly. In the next 2 classes, maybe I finish the syllabus. And you can understand these whatever I have taught in last 2 days. In lecture 7 and lecture 8. All these lectures are very important. If you don't understand this system, you cannot understand HVAC. HVAC is total conceptual subject. Total conceptual subject. You have to have a clear idea of what pipes are running, what ducts are running, how it is running, what distance is to be kept. I have clearly written all the distance, you can see. All the heights and parameters which you have to know. Thank you, students, for attending the class. I hope you understood the class. If you don't understand, you can always chat me. You can always talk to me over phone. And after the lockdown is over, you can always come and discuss me about the drawing. You have everything in the YouTube that will help you. Thank you.